Hello and welcome to this IB Maths Intense session, working with triangles, our 7th video on this third topic of geometry and trigonometry and working with triangles. And this time we're going to be taking a look at the cosine rule, which we can find in the syllabus under SL 3.2. And there it is. There's the syllabus content, and you can see there the cosine rule is given to us there in a number of forms, and we're expected to be able to know and apply how that works. So let's have a quick bit of investigation to see what the cosine rule is and how that works. And we'll start by looking at a derivation. And the cosine rule enables us to work with angles or sides where we don't have the information that we had that enabled us to use the sine rule, where we had a pair of an angle side pair and then another side or another angle. So let's have a look at this triangle that I've just sketched here, and let's do a little bit of work on it and see what we can derive, which might help us in those circumstances. So if I drop down this height of the triangle, I'll call that H. Let's just mark an angle there because we'll be interested in that in a second. And let's mark this point D where that perpendicular meets the line AB. This length here between A and D we can call X, and so the length between D and B must be the difference between C and the total X on the other side, so it must be C minus X here. So we've marked that up. Let's see what we can now investigate about the various bits of that triangle. So let's use a bit of Pythagoras to start with. So if we look at Pythagoras for the triangle BCD, the one on the left-hand side, what that tells us is that a squared, which is the hypotenuse of that right-angle triangle, is equal to h squared plus c minus x squared. And if I expand that out, I get h squared plus c squared minus 2cx plus x squared. That doesn't really mean very much right now, not that helpful. So let's take a look at the triangle on the other side. So we'll do Pythagoras again, but this time on the little triangle ADC. And this time Pythagoras is telling us that b squared, there's the hypotenuse this time, b squared is equal to x squared plus h squared. So I can create an expression for h. So h squared must be equal to b squared minus x squared. And I'm now going to substitute that back into this first expression to get a squared equals, well, h squared is b squared minus x squared. So I'm replacing the h squared here with b squared minus x squared plus c squared minus 2cx plus x squared. And you can see that there's a minus x squared and a plus x squared, so those are going to disappear. So I've now got a squared equals b squared plus c squared minus 2cx. Not that helpful, again, because I don't know the value of x, whereas normally I'd expect to know the values of a, b, and c if I was working on a problem. So let's see if we can find an expression for x. Well, if I look in that triangle ADC again, I can see the angle A there using a bit of simple trig ratios. Cosine of A, well, cosine of A adjacent over hypotenuse, that would be x over b. And that tells me that x, I can create an expression, is equal to b cos A. So I can now go back to this expression here and substitute that in for x. So I've now got a squared equals b squared plus c squared minus, so I've got 2c times b cos A would give me 2, let's just put it in alphabetical order, 2bc cos A. And there I've got it. That is, we've just derived the the cosine rule for triangles. So now, if I've got lengths B and C and an angle that is not included, that is included, which is cosine A, I can work out the length of the other side, A squared. So there is my derivation of the cosine rule. Now, the cosine rule can be written in many different ways. So there's the version there, a squared plus b squared plus a equals b squared plus c squared minus 2bc cos a is the one that we just derived. But if I was interested in finding the value of the side b, I could, like we did before with our formulae for the area of a triangle, I could change this and make this b squared equals, well, it would be the other two sides, a squared plus c squared minus 2ac, and then the angle that is paired with the side b is cosine b. And I could have c squared would then be equal to, well, the other two sides, a squared plus b squared minus 2ab, there they are again, and this time it would be cosine c. So these are all ways that if I've got two sides and an included angle, I can find the third side. But what if I wanted to find an angle? Well, I can just rearrange the formula. So if I go with the first formula, I could rearrange this one and find that, well, 2bc cos a, if I move that to the other side, is equal to b squared plus c squared minus a squared. And then dividing by 2bc gives me that cosine a is equal to b squared plus c squared minus a squared, all divided by 2bc. So there's an expression that I can derive from the earlier ones that will allow me to find out the size of a missing angle when I've got all three sides of the triangle. And again, if I wanted to find the angle B, I could just modify this formula. So instead of being b squared plus c squared minus a squared, well, it needs to be minus b squared this time because that's the side that is paired with my angle B. So I would have a squared plus c squared minus b squared this time, and then on the bottom 2ac, the two sides that include the angle B. And then again, if I wanted the third angle, cos c, I could again, this time it would be a squared plus b squared, because they're the two sides that include the angle C, minus c squared, all over, this time it would be 2ab. So depending on the triangle and the labeling of the sides, you can modify the formula so that it fits the situation that you've been given. Just check out the logic in each of those so you are able to pick the right one. And if you look on the formula sheet that I've got an extract from you here, you'll see they only give you one variant, and that's c squared equals a squared plus b squared minus 2ab cos c, or the angle version of that, cos c equals a squared plus b squared minus c squared over 2ab. So if you're in a situation where you want to find a squared or cos a, you need to modify the formula accordingly so it fits. Let's do a couple of quick examples. It's pretty straightforward. Just be careful with the with labeling, etc. So here we've got a triangle. We've been given an angle, an included angle, and the two sides that include it, and we've been asked to find the missing side. So labeling the side, the angle is at A, so the opposite side there can be labelled as A, and this is side B, and this is side C. So I want a variant of my cosine rule here that is for A squared. So I'm going to write that down. Always a good idea when you do an exam question, write down the formula just so you know what your starting point is. A squared equals B squared plus C squared minus 2BC cos A. That's the version of that formula when I want A squared. And then it's just about substituting the numbers in. A squared, well, the other two sides are 14 squared and 20 squared, and then minus 2 times 14 times 20 times cos 100. And if I work that out on my calculator, taking good care, a squared equals 693.24. And then remember to take the square root. Now, I'm just going to reiterate that because I've seen the mistake made so many times that people leave the value for a squared. But of course, we need to square root it to find the value of the length. And you can sense check that against the triangle you've drawn. Clearly, the length A is not 693 centimetres. It's the square root of that, which is 26.3, which seems to fit a lot better. Let's have a look at an example where we're not finding a missing side, but this time we're finding a missing angle. So we're given the three sides of a triangle, 7, 8, and 9, and we want to find the missing angle that is marked on the diagram, the angle ACB. So I'm just going to label the sides again. So the side opposite the angle A is marked as A, this one's B, and over here is C. So I want my version of the formula to be for the angle C. So I want cosine C, and then just looking at the way the formula works, it's going to be the other two sides. That's A squared plus B squared minus the third one, which is C squared, the one that matches the angle that we want, all over 2AB. So again, just going to put the numbers in there. That's 9 squared plus 7 squared, yeah, minus 8 squared, all over 2 times 9 times 7. Work that out in the calculator, and it gives me 11 over 21. I'll leave it as a fraction. And then that's not the size of my angle. I need to take the cos to the minus 1 inverse cosine of 11 over 21 to find out the value of the angle, and it equals 58.4 degrees. Now, do not worry about the cases of ambiguity that we talked about when we were using the sine rule, because remember that for the cosine, if the angle is between 0 and 90 degrees, it's positive. But when an angle is between 90 and 180 degrees, so an obtuse angle, it's only for the sine ratio that it's positive. So the cosine would be negative in here. So it's only the sine ratio where we get the ambiguity. So here there's just one solution, 58.4. You might well get a problem which has a mixture of things in it. Just to give you a flavour, here's a mixed problem. We're given a triangle which has been split into two smaller triangles. We're asked to find the value of cosine theta and the missing side x. So the first thing I'm going to do here is imagine here's my side A. I'll call this one B, and I'll call this C. So this would be my side A, this would be my side C, and this would be my side B. So I want cosine A. So that's equal to B squared plus C squared minus A squared all over 2BC. So there's the variant of the formula, and then just put the numbers in here. That's equal to 2 squared plus 5 squared minus 4 squared all over 2 lots of 2 times 5, which works out nicely. So cos A, or cos theta, which is what we're asked for, is equal to 13 over 20. Now, we don't need to work out the size of the angle because the question just asks us for the value of cos theta. So that was our part A. Part B, we can go back to our triangle and relabel this now because we've got the larger triangle to deal with because we want to find the size of the missing side x. So labeling this, I want the value of, well, a squared is where I'm going to start. So a squared equals b squared, because this would be side A, this is side B, and this is side C, and that triangle. B squared plus C squared minus 2BC cos A. And then I'm just going to substitute my values in there. So A squared equals 5 squared plus Side C is 2 plus 1, 3 centimetres. 5 squared plus 3 squared minus 2 times 5 times 3 times cos A or cos theta. Well, we worked that out in the previous question. That's why I only asked for the value of cos theta, which is 13 over 20. So if I work that out in the calculator, A squared equals, that comes to 14.5. But of course, that's the value of A squared. So square rooting A equals 3.91 centimetres. And sense check that against the triangle. Does that look sensible? Yes, it does. We're talking about sides of 5 and 3, so 3.91 looks eminently sensible. So it's nice and straightforward, the cosine rule. The only thing that's a little bit tricky is just the rearrangement of the formula so that you get what you're looking for, given that the formula sheet only has one version of it. Be well prepared to rearrange that so that you've got expressions for either A squared or B squared, or for cos A or for cos B if you need them. Anyway, that's the cosine rule. Hope you found that useful. Thank you so much for watching. Don't forget to like this video, subscribe to my YouTube channel, IB Maths Intense. Tell your friends I'm here, obviously, and drop me an email on ibmathsintense@gmail.com. If you've got any comments, any feedback, any things you'd like to see, spotted any mistakes I might have made, heaven forbid. But in the meantime, enjoy your maths and stay healthy.